I think it's now recording. Do people see any indication that it's recording? Yeah? Okay. Great, thanks. Thanks for catching that, Lupe. So what am I doing? Talking about the derivative. Got my iPad here. We've got a function. We've got a point on the graph of the function. We call this a point of tangency. That's the place where the tangent line touches the graph. It kisses the graph there. And so m is going to be the slope of that tangent line. So the tangent line has got an equation, so that we've got point slope form. But we know that y naught is the y coordinate of that point of tangency, so we can further refine the equation of this tangent line, and then it's the slope that we want, okay? That's what we're interested in. That's the only other thing that we need. And so we've defined the slope of the tangent line in terms of the slope of the secant lines. And we use this idea from Leibniz and Newton to say, take the slopes of these secant lines. So here's a slope of the secant through the point of tangency and the point x naught plus h, comma, f of x naught plus h. And then you take the limit as h goes to 0. And then this is the slope of your tangent line. This is your m. Okay. And we call this m the value of the derivative at the point of tangency, at that x naught, the input that gives us the point of tangency. So this was our introduction. This is how we understand derivatives. This is our introduction to derivatives. This is how we understand derivatives and where they come from. And today's activity is going to let us exercise this a little bit. But let me say one more thing. This whole process on the previous page lets us start with an input and calculate this derivative value. And again, the way we calculate it is through this limit. Okay. But this defines a function called the derivative of f. And we denote that by the function symbol f prime. Okay. So what we're going to do today is we're going to do a little activity where we start with a graph of the function and we start sketching the graph of its derivative. Okay. So that's what we're going to do today. So start practicing the art of looking at the graph of a function and then imagining what the graph of the derivative must look like. Okay. So technically, the graphs don't live on the same pair of axes. So you just got to remember this. Because the units on the output are different. Okay. So just remember that the units on the output of the derivative are different from the units on the output of f. We can sketch them on the same set of coordinate axes, but the output means something different. Okay. Just a real small technical point, but I would be remiss if I didn't mention it at some point. Okay. Any questions about this? These ideas that we're studying? No, no questions? Okay, and not hearing any questions, I'm going to make Lupe a co-host. And let's do an activity. And I think this will take us maybe a half hour, maybe a little bit more. I am going to share a browser. If I can find one.
Jay has a question, but she says the mic's not working.
Oh, okay. I understand. I'm looking for chat. So Jet, just throw it in the chat. That's cool. If your mic's not working, can you ask it in chat? Okay, we'll wait for Jet to articulate her question. Okay, so first thing I'm going to do is I'm going to throw into chat the instructions for our activity. Right, and I'm going to share my browser now. So these are instructions I believe that I sent out this morning. If you haven't taken a look at them, that's no problem. It's a Google Doc. What we're going to do is that I'm going to try a tool. I've never done this before, so you're going to be helpful to me to help troubleshoot this. I think it's going to work. We're going to use what's called the Google Jamboard, and this is a new tool to me. And we're going to use it as a collaboration space for breakout groups. Okay. So I'm going to throw everybody into breakout groups, maybe of size 2, 3, or 4. I haven't decided that. I haven't thought that through. Yeah, maybe 3 would be a good number. And then somebody in that group needs to go to this link here, this link to this Jamboard. Okay, and I'll show you the Jamboard in a second. And then that person should make a copy of the Jamboard. And there's a little icon on the Jamboard. You can click on it and you get a menu. And then there's a selection you can say, make a copy. You've probably done this 100 times. Make a copy and then share that copy with everybody that's in your group. And a good way to do that is in your breakout groups chat. You might have to adjust the sharing permissions so everybody can work on it and edit it. But I think I've got them set so everybody can edit it now. And hopefully you're making a copy won't change that. So I'll repeat, I'm going to put everybody into breakout groups, into small groups. Somebody in that group has to go copy this Jamboard so your group can work on it, share the URL to your group, and then you get to work. Everybody opens up a browser and starts working. Okay. So let me show you what that activity looks like. So heck, I'll just go to the Jamboard with that link. So here's the Jamboard. There's a little summary of what you're supposed to do here on a Post-it note. That's not important. The Jamboard here consists of 8 graphs. So here's one of them. This looks like a parabola. And they're all graphs of elementary functions. In fact, I think they're all polynomials or exponentials. There's one monomial, one reciprocal. I think it's 1 over x or something. But they're all elementary functions. And that doesn't make a big difference for what we're going to do. Each frame here has a graph of a function, and down here at the bottom, it's got 4 lines. You can click on the line and move it around, okay? What I want you to do as teams is to use these as tangent lines, okay? So you're gonna pick an input for the function, and that's gonna give you a point on the graph, and that's gonna be your point of tangency. So let's say here, I'll just do this so we all can see it. I'm going to pick this point as a point of tangency. And now what your job is to estimate the slope of the tangent line at that point of tangency. So you're going to grab a tangent line, and you're going to want to place it at that point of tangency. But you're going to you need to angle it. And so up here in the left-hand corner, when I mouse over, can you see that little dot with the semicircular arrow on it? It might be pretty small for you, but that's a rotation handle. So you can grab that and you can rotate the line. You can rotate it so it has the slope of the tangent line. So I'm going to estimate that. And then you place it at your point of tangency, and that's your tangent line. Okay. So you just sketched a tangent line to the graph of the function. Now you want to estimate the slope of this tangent line, okay, using the grid. And so here, the tangent line goes from 0 right here, and then I go to the left, and it's going to go to -2. Okay, so that's a delta x of 2. And then the delta y here, let's see, it starts at -1 at this end, and at this end, it looks like it ends at about 3.5. Let's say 3.5. And so that means the delta y is 4.5. And if I were to write down the formula, and I encourage you to write down the formula, you'll see that the slope is a -4.5 over 2. And so that's -4 over 4. And so this slope here is a -1. Okay. So on paper, you calculate that this has a slope of -1. And then the next thing you do is you say, okay, here's my point of tangency. And so this is the point on the x-axis. Here's the input. Now I'm going to plot the coordinates of the derivative. So in this case here, it's like whatever this x coordinate is. And then I'm going to plot -1. And so I'll do that here. Input and then down to -1. So I'm using the pencil tool and I'm plotting that point. And so that's a point that's on the graph of the derivative. Okay. And then you just repeat this for another input and another tangent line. Oops. And another tangent line, find another point of tangency, and repeat that till at least once for each of the tangent lines. So you'll get 4 points on the graph of the derivative. And then when you see those points, maybe you'll be able to visualize what the derivative graph looks like. Okay? Everybody understand that? You ready to try it? Ready to see if it works? Okay, so there's one problem that I encountered this morning. I think I fixed it, but it's possible that when you drag a tangent line onto the graph of the function, it's possible that the tangent line will sit in the background of the function. It'll be under the graph. If that's the case, you can come over to the right-hand side, and there's a little menu here. The little 2 vertical dots say there's a menu. You can click on it, and then the order, you can bring the tangent line forward or backward. And so I'd say bring it to the front, and then it'll come out in front of the graph. Okay, so if you have problems seeing the tangent line, you can modify the order that these graphs sit on the page. Let me erase my work here. When you get into groups and you start, here are all the graphs. Oops, here are all the graphs. You can see them here summarized. You can start with whichever one you want. I would suggest that you start with something that looks like a parabola, just to get practice. And then you can move on to something more sophisticated. Okay. Any questions? No questions? Okay. So,
Professor,
yes.
I'm so confused by that. Sorry. How you're coming up with the slope and things like that. And like, I know I mean, you're just picking a random point. I get that. And I get, how you're lining up the tangent. But I'm not understanding how you are getting the slope from that.
Okay. Good question. So let me share my iPad and I'll draw a picture. Well, no, I'll do this on, I'll go back and forth a little bit. So we'll start with the Jamboard. Okay, so here we've got a Jamboard. You're going to pick a point and place a tangent line at that point. So here my point of tangency is along the y-axis. Okay. Oop. This doesn't want to drop it. So what I hear you asking, Jet, is how do you estimate the slope of this tangent line?
Yes.
Okay. So
and your delta and all that stuff.
Right. So the slope is the rise over run. Right. The slope of a line is a rise over run. So think of this tangent line as the hypotenuse of a right triangle. And there's all kinds of right triangles you can see here with the grids on the graph. And you can choose any right triangle you want to do this calculation, this estimation. You know, I like to choose them where my tangent line goes right through two grid lines. So let's choose this point here, which looks like, well, yeah, let's choose this point and let's choose this point here. Okay, so this point looks like it's got coordinates, what, 0.9. I'm gonna write this down on my iPad. And comma, what? I gotta look way over to the left. Looks like it's 0.9 comma 3. And then the other point, which is right here, looks like it's got coordinates negative 0.7 comma 0. Okay, you with me?
Yeah.
So now I'm going to switch to my iPad.
Can you mark those points on the bottom, like so I can visually kind of follow?
So I think I chose this point right here. I think I chose this point right here. And so if we were to draw the other vertex of the triangle, the right triangle, it would be right here. Okay, is that good? Is that what you wanted?
Yes, thanks.
Okay.
Makes it easier. Go ahead.
Yeah. So now I'm gonna share my iPad. And if you're, so those are still on the Jamboard, so everybody can see that while I switch back to my iPod or my iPad. If it would share.
And you're saying the rise is 3? Because
So if you look, if you look on the y coordinates, the y-axis, way at the left, that's where the numbers are. You can see that the So you see that the coordinates of that highest point is 0.9 comma 3.
yeah,
Okay, you good with that? Yeah, and so now let's calculate the delta y and the delta x. So the delta y is the difference in the y coordinates, and the delta x is the difference in the x coordinates, but it's important to write them in the same order that you wrote the delta y entries. All right, so delta y is indeed 3, you're right. And then the delta x is 0.9 plus 0.7, which is 1.6. So my slope is delta y over delta x, 3 over 1.6, which is about 2. It's slightly less than 2. But for the purposes of what we're doing here in this exercise, you know, estimating it to be about 2 is good enough. You can use a calculator and see that this is like 1.8 or something. But 2 is good enough. Is this helpful? Is this what you wanted to?
Yes, thank you.
So let's complete the circle though here, and let's go back to the Jamboard. And so what I would do now is I'm looking at the point of tangency here at 0, right? This is my point of tangency. Now I want to plot the point 0 comma 2. So I'm going to come back and say I'm going to plot my derivative points in green. I go out 0 to 2. So there's my the point on the graph of my derivative. And I'm going to get rid of these so people aren't confused. Okay. And the only thing that this new point you plotted has in common with anything you've done already, visually, geometrically, is it will share the x-coordinate of your point of tangency. The y-coordinate's going to be possibly, it's going to look unrelated. You know it's tied together with the slope of a tangent line, but the point's just going to be somewhere along the vertical line that goes through your point of tangency.
Thank you so much.
You're welcome. I'm sure there were 12 other people in class that thought that was useful. Okay, I'm going to stop sharing the Jamboard. Actually, I'm going to go back to the Jamboard.
Really quickly,
yeah,
to what you were saying, for the point of the derivative, so you're basically taking the slope and you're doing 0, 2.
In this example,
Yeah.
I plotted the point 0, 2
Mm-hmm.
because 0 was the x-coordinate of the point of tangency I was working at.
Okay.
And 2 was the slope of the tangent line, right? I just calculated the slope of my tangent line.
Okay.
So remember, this point here is the coordinates x comma f prime of x, and f prime is the slope of a tangent line to f.
Okay. All right.
Good?
Thank
You bet. Okay, so I'm going to erase this too. Okay. So what I'd like each group to do is do this for a bunch of the graphs that are in my collection. There's 8 graphs in the Jamboard. Do this process for a bunch of graphs. And in the Jamboard, you can all be working at the same time. If you're working through a web browser and you've got the URL loaded, you can all be working at the same time. I would encourage maybe 1 or 2 people to be doing this at a time so you can be talking about it. Check each other's work. If a couple people estimate the slope of a tangent line, you can compare the numbers you get. So work collaboratively, work efficiently, and do things in parallel where you can, and explain what you've done to other people too, especially if you're working in parallel. And everybody should, I encourage you to all work on the same graph at the same time, but I think the Jamboard will let different people work at different boards at the same time. But I'm not sure. I'm not sure about that. I think maybe you'll have to be on the same frame at the same time. We will learn how these work. All right, I'm gonna, it doesn't look like I'm sharing anything. So now I'm gonna send people into the breakout rooms. So here, I'm gonna post the instructions back into the chat. The instructions basically summarize what I just told you all to do. And then remember, one person will go and make a copy of the Jamboard and share that copy with everybody in the group. And then you'll work on that copy. Don't work on the version that I gave you. Make a copy and work on your own. Okay, so with that, I'm just going to throw everybody into random groups. And we've got 23 people, 21 if you take out Lupe and me. So I'm going to make 7 rooms. Should I do 7 groups of 3? Yeah, let's do groups of 3. Okay, any questions before I shoot you into rooms?